자리에 불어. 자리에 불어야 돼.
Don't mute. Can you hear me? So it's time for the class. Okay. Okay, it's time for the class. So
Okay, last.
I remembered I give you a homework. Have you finished that homework? I finished the homework, how to calculate the position error. The position error. Finish the homework. Let me see. This one, a sleeve type workpiece is shown in here. The homework, how to calculate this location error, the position error, location error. Could you type your homework in the chart column? No one answer me.
Yes, Laoshi.
So have you finished the homework? This question, how to calculate the location error of the last one, this one.
Laoshi, it's very difficult. Could you please solve it for us?
This one.
Yes, Laoshi, it's difficult for us to solve. We tried.
Have
Yes, Laoshi,
Have
it's
you
better
finished-
you can help
have you
me to
finished
solve
that?
this.
Can you take a photo to the child column?
Yeah.
What?
This one. Can I see you? How to answer the state? Original page. Can you? Oh, you can take a page, right? Take a photo to the. Okay, you can do around here. And that's when if you finish the homework, just take a photo and type to here, the column, the child column. Okay. Type to here, or take a photo to here. So give you 1 minute or 2 minutes to take your photo. The answer steps. The answer to here. No, okay.
You know, you go like this way.
Yeah.
I try the same.
Yes.
I did.
Give 5 minutes to finish the last one. Okay? 5 minutes to finish this picture. To finish this one, how to calculate the location error. If you finish that, just type your answer to here, to your chart column, okay? Or take a photo to here. So this is the last class, okay? After the class, you will have the exam.
Laushi,
You
today is the
have
last
the exam
class.
schedule. This is the last class, okay?
Okay, Laushi.
Huh? You come to exam. You have the schedule. Schedule to June 10th. Have the
She's asking about.
Huh?
She's asking about solution. You like to give us some solution and then.
exam what? Suggestion for the exam. You just for this chapter, just do this like the homework, the same
The researcher have a lot.
the same single question. The same question. Same question in the exam.
Researcher have a lot of work.
I love the word.
Yeah.
The word.
Should be a lot of math and drawing.
The math and drawing.
Yeah.
But you have to feel that actually.
You say?
Hmm?
You say?
If they didn't have a lot of people to that, but this is your course, the fundamental course, you need to finish that. So this, I think you just to finish the homework. I think you have to be there.
There's enough. There's enough.
There's not,
Enough.
yeah. And the course, the course, the homework the teacher give you. And you just to read every question and you will to pass the exam. Huh? Yeah. I think the suggestion that the questions I give you, you just did the questions I give you in the class. Maybe it's the same. Some questions is the same. Ooh. So you need to finish every questions the teachers give you. I'll try. You finish this one? Huh? Pass?
Laushi.
Hello? There's some question? Have you finished this one? Location error, calculate the location error. Record, this already recorded. Yeah.
Yes, 老师。
So can you give your answers?
Actually, 老师, I'm trying, but I don't know why it won't be sent. Maybe they have some problem, I think.
You don't know how to do that?
No, I know, but I can't send here because the file.
I can't see. I can't see. You can't see the picture?
Laushi, I can see the pictures, but when I put the file in the chat box, it won't be sent. I can't be sent.
You can send it to the chat, right?
Yes,
Here?
yes, Laushi. Yeah, that's the problem.
Okay. You can chat here. Can you just send to WeChat?
Because Bob meeting has different issues. That's why sometimes it was take some problem. And I'll send you in your email or WeChat.
WeChat. I mean email.
Yeah, sure. Yeah, in your email or WeChat, I'll send you.
Email is you see. This is my email. Can you see my email address?
Yes, Laushi, I'll send it. I'll send.
Can I send you to here?
Okay, sure, Laushi.
Have you sent my email? Hello? Have you sent to my email?
Yeah, Laushi, it's sending. It takes some time. I will inform you when it will be sent.
Okay.
Okay.
I will check
Give me some
that.
time. Give me some time. Yeah, please give me some time.
I haven't received that. Okay, so continue our class. So maybe next class I will discuss or discuss this question. Okay, the location error, how to calculate the location error. So please send to my email. Okay. When you finish that, please send to my email. Okay. So continue our class. So this class we will talk about the clamping force, the clamping of the workpiece. Okay. So for that homework, just send to my email. And this class we will talk about the clamping of the workpiece. Okay. So we already talked about how to calculate the location errors. And so when you locate this workpiece, and then you need to clamp it, to let it fixed in the motion tools. So how to how to design the Clampy device. So today we will talk about that. So firstly, we need to know the elements of the Clampy device. The first one is the power source device, okay? Because you need to clamp the dog piece. So you need the power source device. So some powers is like this figure. Like this figure, okay? So this figure, this is the workpiece. The five is the workpiece. 5 is the workpiece, okay? And what is this one? Can you see that? Can you see that? This one, what is this one? This one? Clampy device. No, I mean, I just see this one. I just say this one. So this 5 is the workpiece. So this one is hello, can you see this one? This is the locator device, okay? This is the locator device, okay? This is the pin. It's a long pin, right? And this is also is the locator device. It's suppose this one. And the pin to restrict the what? The rotation around the X and the Z, right? So like this workpiece phase degrees of the fringe is just Z rotation. I mean that the workpiece can rotate around the Z. But there is the 4 is a abrasive plate. 4, 3, 2, and this one is called the Clampy device. Okay. So the power source device is one. One is the pneumatic cylinder. Do you know what is a pneumatic cylinder?
Pneumatic cylinder.
Yes.
It's a hydraulic cylinder.
Yeah.
It contains hydraulic fluid.
You already learned that course, right?
Yes, yes. So we did the exam yesterday.
Yesterday, you did the exam yesterday, okay? So that is the pneumatic cylinder, okay? So this one. And someone is the electric cylinder. So this is a pneumatic cylinder. And yeah, it's a difference. How to go different? Electric is from the electricity. So this one is from the pneumatic is from the water, yeah, fluent. I mean the source, the power source is different, okay? And 2 is wedge. This is a wedge. So this one to push the wedge push this one. 3, the wheel collects the pressing plate, and the pressing plate can give this workpiece a force, right? So all of this is called the clampy device. And what is the clampy element? Can you see the picture? What is the clampy element?
I see 4.
Yes, 4. Hello, online students? Can you
Yes,
listen
Flossie.
my answers? But my questions,
Yes,
what is
Flossie.
the power of the clampy element? The clampy element is 4. Is 4 because it's to clamp the workpiece, okay? And intermediate force transmission mechanism, what is that one? Intermediate force transmission.
Immediate first transmission.
Yeah, the No, first is the power source of device. First is the power source.
The immediate is 2 and 3.
2 and 3. This intermediate source, intermediate first transmission. Okay. So elements of the clamping device and requirements. Three phases of intermediate first transmission mechanism. The first one, be able to change the direction of the clamping first. Right? Let's see this one. This is the pneumatic cylinder. Hit first like this place, and this direction, and it can to push this device to this direction, the horizontal direction, and the first transfer to the wheel. So the wheel transfer to the plate. The plate is to have this direction first to push the workpiece tight in this surface in here in this surface, so it can to clamp the workpiece very tight. Okay, it can to change the direction of the clamping first, and be able to change the magnitude of clamping first. So like this one wedge, this wedge can to change the clamping force, the magnitude of the first. It means it can to magnitude the clamping force. And how to magnitude the clamping force we will discuss later. And be provided with self-locking mechanism. And also the wedge is a self-locking mechanism. So what is the self-locking mechanism? We will talk about later, okay? So the requirement for clamping devices. The first requirement is be accurate and rapid action. The second one is be convenient and labor-saving operation. It means that easier to use, be secure and reliable, be simple instruction and easy to manufacture. Yeah, this is the requirement. So the elements of the clamping devices is a manual clamping device or the power clamping device. The manual clamping device, like a screw, you just use you just you clamp it by hand. It's a manual clamping first device. Okay, the clamping mechanism, the screw, and another the power clamping device, like electricity and the pneumatic. Yeah, that is the power clamping device, and the power is to transfer to the first transmission mechanism, okay, and the clamping element, then to clamp the workpiece. So the principle of the determine clamping first. To determine clamping first is just to determine the direction of the clamping first, clamping position, and magnitude of clamping first. The first one.
To clamp device is what? Push it.
Where?
To clamp the device.
Clamping device is what? Is to.
What does it mean?
Huh? What does it mean?
To put force on the.
This is all of that is called the clamping device.
I mean, the term clamp means to push the workpiece with force so that it doesn't move.
Like I mean, for example, this is the how you see. Let me see. How you see my picture? So this is the clamping device. This one is screw, the clamping device. So what the question is that?
I mean, clamping is to to hold the
workpiece, yes. To clamp it where? Clamp to fix it where it don't move.
Move when you're drilling.
Yeah, draining or something like that. Draining that. So the difference is clamping and the locator that. The locator device is like this one is this is the locator device. This is the locator, this is the pin, right? The pin that this no first here. The pin that no first here. So the workpiece must to contact the pin that's to support it. But the clamping first is this is the clamping device. If there's no first, see like this one, right? This a plate is this one. This is no first, no first here. Plate 8. So this plate cannot restrict the degree of the freedom. So if there is a screw and you have to clamp it, screw it, there have some force. The first is depend to fix it where it doesn't move. That is the difference. So the clamping is just give this workpiece of force. The clamping is a clamping force, okay? So determine the direction of the clamping force. So the one principle is the main clamping force should point and be perpendicular to the main location surface, making the workpiece location stable and reliable. So this is principle, right? So like 1 and 2. This is the workpiece is here. See that? This is the workpiece. And this is the workpiece, okay? So in order to pulling a ruler, the surface, there's the hole. The hole, like a drill, the hole. This is not a drill, like a ruler, right? Ruler, the hole. This is ruler, the hole. So could you think this one and this one, the clamping first from this direction or clamping first from this direction, which one is correct? And give me some reason. Why? The clamping first is from this direction. The clamping first is from this direction. You need to rumor this hole. A or B?
A.
A is right.
Yes.
You have some different answers.
A is right. Or B is right.
How much big is this part?
This is the part, okay, this is all this. Here, this is all this. So, which one is the direct, is the right, is right, and it is the reason, or the reason?
A, actually, because we want to drill a hole in that's in A, right? That's in capital A.
Mm.
We want to drill a hole there. So if we put the clamping force this way, the datum A is directly perpendicular or parallel to the clamping surface and straight. So if you drill the hole, there won't be mistakes. The hole will be the workpiece fixed. So the hole is gonna be straight instead of curved. But here if we clamp downwards, it's not gonna be 90 degrees. It's not gonna be perpendicular, which means the workpiece might turn when the hole is not gonna be straight.
So because you need to drill the hole, right? Rumor the hole, okay? The hole. So the A is the locator surface. Like this principle is that main clamping first should point and be perpendicular to the main location surface. So this is the main location surface, right? So the first is perpendicular to the main surface, right? To the main surface. So stay and that is the workpiece is stable and reliable. So it's like this one. So this is the surface, the locator surface, and this the clamping first is from here is parallel to the main locator surface, and the first here, so the hole will inform. Going to be like degree, like remove the hole. The hole can be circle. Right. You know, so it's very circle. I mean that this line is not it's not horizontal, it's not straight. So the one principle is that the clamping force is to be particular to the locator, to the main location surface. Okay.
Which part is here?
Huh?
Here, which part is here?
Who's part this?
Drilling machine or clamping?
This is the rumor. The rumor is to rumor the hole.
The groove.
I'm asking about this.
That's the drilling.
Like you're drilling the hole.
Yeah.
Like this one, like you're drilling a hole. That's not drill because it's already have a hole, okay? So it's to like enlarge the hole. And another one, the second principle, the direction of the clamping force should avoid the directed towards the direction with no rigidity of a workpiece, so as to eliminate the effect of clamping deformation on the machining accuracy as much as possible. So, like this one, this is the workpiece. Have you seen the workpiece? This is the workpiece, okay? And this is the workpiece, okay? So this is the fixture. This is the fixture. So now this is the fixture, like this one. So which one is better?
Drill the hole where?
Now draw the let me see. Now drill the hole. It's just milling the surface. Oh, no, not milling the surface. Let me see. To drill the hole. No, this is a leaf type. Leaf type okay. Maybe this is okay. Maybe this is okay. Yeah, and drill the hole. Not drill. It's the rule the hole. Enlarge the hole.
A is better.
A is better. Why?
Because then we should avoid the parts with low rigidity.
Low rigidity.
So the parts
Rigidity.
that is strong, we shouldn't put the clamp there because the clamp might deform that part.
Which one is deformed? B is deformed or A is deformed? I mean the workpiece.
I think B is correct.
B is correct.
Yes.
Why?
Because this is the direction of the clamping force to avoid directing towards the direction of low rigidity of its workpiece, so as to eliminate the effect of clamping deformation in the machining activity as much as possible. So
Yes.
if you look at A, you realize that the side that F2, the force, is pointing to is very fragile, it's not strong. So if you clamp that side, it might end up breaking the workpiece. But if you look at where this force is heading towards, this force is directly perpendicular to the other surface, which means the length on which the force is being applied to is longer, and therefore it has an increased rigidity. Therefore, there's no way it can break the workpiece through clamping. There won't be clamping information.
Do you have other reasons to this workplace? So like the part, the plan A, the fixture. The fixture is like to use the like a chart, right? This is the chart, three chart, four chart to clamp the office, right? So the first is the direction is from this one, is from this direction. But this is very thin. This thin is weak. So have a low rigidity, right? Low rigidity. So it's rigidity. So if we clamp it. So this office where information default have a very big shape formation, right? A big deformation. But this clampy two, his direction is clampy first from this direction. From this direction, he don't to clampy the first don't like from this direction. From this direction, so just to clampy this office from here. Here is not very thin. It is a thickness. It's a large thickness. So the office cannot be deformed, right? So the B is a better, right? So the principle 3, the direction of the clamping first should be good to reduce the clamping first as far as possible. So, like here, I think which one is better? This one, right? Because it's leader A is better, right? Either to use his gravity and the cardiac is gravity, okay? So use the gravity, it can to has a low clamping force and then to reduce the allergy, okay? And the clamping point, I mean the clamping force should act against the locators or within the location area, composed by several locators so as to avoid clamping the location of workpiece. So, like this one, this clamping here, clamping first is from here, right? So, if from this point, the workpiece will rotate. So, which point is better? I mean, this one.
The clamping device down the line of the other one, so that if they are in line, it clamps into the
Right? The clamping first should act on the part with good rigidity to reduce the clamping deformation of the workpiece. So like from here, there is a torque, right? So if the clamping first, the working point is here, it produces a torque. The torque is made the workpiece is rotated. Got that? Have some question? I mean that if this point is here, this is a workpiece. So this workpiece is here, and this is a and this is clamp is here, and is here. If you work, this point is a force. It produces a rotator to the workpiece, right? So like this one is the first it's working here. It produces a rotator. Rotator is a torque, produce a torque, and the workpiece will rotate it can clamp it very well. But if the point is working here, is in the line if this point, because this is a first and this is a first, so there's no, they cannot produce the rotator, produce the force. Yeah, so this one is not good. If this point is here, it's good, and this one,
The clamping device must go forward.
go for here, right? Not here, right?
Yeah.
Because this clamp first is there to the support the locator device. Okay, the locator device is means that this one, the clamping first is go forward to here, the clamping here, right? Got that? As a question? And that one, A and B. B is better, yes, because A low rigidity, right? The stiffness is low. Because it's very thin. It's very thin. The stiffness is low. If there is a clamp force, they will to produce a big deformation for the workpiece, right? But this one, it cannot produce a big deformation for the workpiece. Okay?
So I think the force is too balanced.
Balance for A.
The force.
Here,
No, the other A.
A
The force is too balanced because
it's balanced.
support. It's not balanced.
You know,
So it causes deformation.
no balance is it means if either this is either a force, this is the difference and it's balance. It's here, no balance because it's a thing, right? Okay, that's some homework. Is that it's just a practice, okay? Don't for the homework, okay? So based on the principle of determining clamping first, try to analyze the clamping plan shown in here. Point out the inadequacies and improve them. Okay, A, B, C. Give 10 minutes to finish that. To think about that.
Actually, did the last class.
And
Did the last class.
this is the last class. This is the last class, okay? Give 10 minutes. 10 minutes. Okay, give you 10 minutes to finish, to analyze. Think about this one. A, B, C. The clamping first is bad or not bad? It's reasonable or not? Think about that. Okay. And then send the homework to my email. Now let's do it.
She's break time.
Sorry, give me. Yeah. Somebody. A, B, C. I'll see. Finish this one. Okay. So you 10 minutes to finish this one and send your homework to my email.
Actually, this one. So which one is the clamp? We need to draw our own clamp device.
No clamping device, just first
We need to draw.
you need to draw just think about to analyze the first from this direction is reasonable or not.
Oh. For clamping.
Yeah, for clamping the workpiece.
Which one work is here?
Which one is the workpiece?
What is it?
This is the workpiece. This is the workpiece. Okay, this is the we shape the block. Okay, this is the pin. This is the workpiece. This is the workpiece. So this is workpiece. This is the V-shaped block. This is the V-shaped block. This is the workpiece. Okay, this is the locator device.
First one is okay. A.
Uh,
A is okay.
uh,
B
mm,
is not okay.
mm,
B, the direction should come from up to down.
mm.
Then for C is the place, the direction is correct, but where the force is strong, because it's not rigid enough. So we can push the force forward in this one, right to the right. Straight
This one, this direction.
oh,
Here. The last one. This one is the
no.
work.
Actually, you can take it to the center of that circle or to the other clamp.
Mm.
You can take it to that side or the clamp. No, so in the middle, no. The force is too much. It's can force.
Where? Come here to show that
This one is work piece.
that is a dash line. So this is a dash line. Dash line.
That's my work.
Dash line. Above the line. Clampy is the locator line.
I just, yeah, the work.
The rigidity is bad.
Yeah.
So we can put this arrow directly under it. But here too, the circle ones
It's okay.
is difficult.
Yeah.
Because you can put it
Yeah.
in this plan. So that
So you're saying from inside.
here. Because if it is here, the floor in this clamp is,
But look at that side.
but this side is it's an up. So it's gonna be a challenge to calculate the exact direction of the force. So if you can put it here, it's better. Because here, any force you put here, there will be another force to counter because of the clamp. So the rigidity is high. If you put it here, it's gonna bend.
If you put your force like that, it can move.
It won't move. It won't move because of this clamp. This locator. You understand? This look, putting it here is okay, but the problem is it's gonna bend the work piece because the work piece is too narrow.
The only force in this way. They have chance to go this way.
But if you put the force here, it's gonna move the. If you put the force here, if here, if here was like a box, it would be easy to put the force up. But if you put this force here, how sure are you the force is gonna go right down? Because this space and this space is safe. And it will be too many calculations need to go inside to get the force because If you want the force to go perpendicularly down and you put it here, remember the surface here is not the same. So not all the force will be distributed.
So we can make force.
If you make the force this way, making the force this way, it's still a circle. You make the force this way. What if this stress rises?
Yeah, make it first here. How to make it first here? Where you first this the surface, right? Not the surface.
The surface. How will you put the force on the surface?
Yeah,
That's the
you
issue.
need to put like a clampy or just a shape and a V-shaped block.
See. So just
Yeah. So you can put it here, it's easier. Because like this one, this is a circle, right? This is circle, so you put first here like this surface. This is straight surface. And this is a V-shaped block, right? So you can put the first here, and you can how to put the first here. You cannot, right? It's not easy to put the first like to the surface. Not a very straight surface that this
Yeah, I get.
this surface. So like this one, this is not a round point, right? Because it's very thinly. It's just very thin, and the rigidity is not very good.
Yeah.
So you will put it here.
Yeah.
Or maybe you can change the clampy, change the locator device. You can do number. And that is the first from here, from here, from here, from here. And this one, not good, right? Because the point here, it means that the first is from here. It's from here, so it and this one, this is low, and this is higher, so it can produce a torque. This torque means that the workpiece will rotate around this point. Around this point, right? The workpiece will around this point, it can leave the surface. So it means that the V-shaped block should go down to here, right? So down to here. Or maybe you can choose number to make this surface. This V-shaped block is the number. If one is bigger, not the width. The width of the workpiece or the V-shaped workpiece means that from here, right? From here to here, and put the first here. That is right.
But also we can take the force and put it down.
If you put you down to put the first down, right?
Okay. Yeah, put the force
Well,
down.
to put the force and the V-shaped block down.
No, I mean, the V-shaped block is a locator. Right?
You locate it here.
Yeah, so if we take the force, it won't put any force. We just
Put this
put the
here.
force here.
Put the force here.
If you put the force here, this will have no force. So just be holding it like a locator. So maybe if you put the force here, the diagram we can see. But if you move this one down, the force here, so
That is okay. And you need that to put the force here, right?
because
Right
we
here.
here this way, so the force should be perpendicular to the sun.
And also
If
it's
you make
okay.
force from this way, how you will do it?
You are going to drill here. You are drilling here. Right? You are drilling here. So and here is still the workpiece. You understand? So if you put the force here, this V block is just supporting the.
And that so first direction is perpendicular to the locating surface, the main locating surface. That's okay. So this is the main locating surface. This is the main locating surface. You have to put first here is okay. And how did you put the first here? You need to add. You need to add some. How do you put the first here? You need to add some like a press plate. So you can to add devices. Now you put the first here. That's how this is the locator device, and you can put the first on the locator device. If you put the first here, you must to design the press plate I mean, if you add some more devices, that's not bad.
Okay.
Not very bad. Okay. Not very better. Very good. Very, very, very good. No, you need more devices. And this one.
Understood.
This one is okay. Yes. Yeah, this is which is not very low. Yeah, it's have a high rigidity. Yeah. Can you understand? Okay, just can you follow me? And the homework. I mean this. Okay, back to this one. Back to this one. Back to this one. Have you finished this one? You can understand. It's very difficult. Can you understand this one?
Yes,
Yes.
but
And this is what you can understand. Maybe it's an exam. You have the same questions here. Now,
Let's solve it together.
you just solve it and think about that.
actually, you know about solving.
So, and then can help you solve it. Just think about yourself. You cannot mind it. You're there.
Very much.
Right.
So there you want to finish this one? Okay. No.
Every time after every.
Every time. And just think about that. Pretty good. It's a break time and 20 minutes to finish this homework, okay? This. A, B, C, A, B, C, the same. Are you sure? Can you think about this one? You think about this one.
Yes.
If you don't have to think about it, and I can give you answers. And for the question, I just give you these questions, and you need to do that.
That's the punishment. Punishment.
And how pass?
Really much.
Yeah. You don't know. No.
Don't mind this. I think he's just looking for a excuse. That's fine. Fine, not good. It's inevitable. Damn. Why do you do that? Hey, well. This one, the location error is at the angle, right? The location error is at the angle between the workpiece and the.
B or C?
C.
Yeah, angle is 90 degrees.
It's between the location error,
Location, yeah.
angle and the D block.
Angle.
The angle is at the angle between the workpiece and the D block.
B block.
Yeah.
Yeah, you say again, the angle,
The location error.
yeah, location error,
It's at the angle between
yeah. Workpiece and B block.
actually the problem I have is that the steps how to go. I just understand, but
The things I have already said that last course,
yes, but it was
last
that one has no
last
angle.
course,
Has no angle.
last is true, I have already read the answers, right? B,
But it has no angle.
it has no angle, yeah, at the same location, the same state. The first one is to think about the non-superposition error. So it has not, and then to think about the position location. The error
This one
position
doesn't
location.
non-position error.
Huh?
There's no non-position error
Right, why?
because the vacuum is the same. It's the same line.
I mean, for the operation, they where the operation data.
This one the operation.
Yes, operation data.
The middle line point.
Why? Why is the middle line required? You know, to make sure you see the equation that we it requires to ensure the dimensions 94. The maximum deviation is 0. The minimum deviation is minus 0.2.
Oh. 94, 94, Okay. 66. 66 point 47. Change. Let's change in y.
You come back to class?
0. Yeah. Plus so logic.
Oh, there's another.
Change in y.
这是 y 啊。There is no superposing the area. No.
Yeah.
Y.
Creation that
Operation data in where
creation data is
Okay, back to our class.
oh let's go.
Hello, class is start. Class is starting. The one here. Okay, class is starting. Okay, so have you finished this homework? No. And I checked the student G0 G59 0100105 I think it just to think about one arrow, one position arrow. So we can to go over
Laushi,
last course, okay?
Laushi, can you hear me?
Huh?
Can you hear me?
This is yours, right?
No. Can you hear me?
Yeah, I can hear you.
Actually, many students have network problems. Some have network issues. So, could you please extend it some time? Some student text me that they will send the homework within today.
You can send me today, right?
Yeah, within today because they have some network problem in different students.
Problem.
Network problem. They will send you within today with this
Okay.
and also with them.
Okay. You can
Okay,
send me another
谢谢老师。
day. Okay. We want to go
Okay.
over. We can go back. Go over the content we talked about last class. Okay. How to calculate the position of the arrow, the location arrow. So they have 2 steps. The one step we want to think about we need to analyze the superposition error, right? There's no superposition error, not right. So back to this question. Is there superposition error or not? So this is the workpiece. You need to make sure the distance here, right? So for this one, the distance, the operation data is where?
Operation data is the reference data.
Here, right? This is reference data, right?
Yes.
Here, it means that it's here, right?
Yes.
So it's here, and for the V-shaped block, the location data is the center of the circle. It's here, right? It's the same or not? It's the same.
But no, it's not the same.
So the operation data is here. It's here. It means it's here,
Yes.
right? The locator data is V-shaped. V-shaped block is the center of the circle. It's here
Actually, why is the V-shaped locator in the center of the circle?
because this is the V-shaped block. It's a V. This is the V-shaped block. V-shaped block is to symmetric here. So his horizontal measure is the horizontal data, right? The horizontal arrow. This arrow is horizontal arrow. This one is that this is the parallel is the perpendicular. The surface is here and this surface is here. So this is the center. So this
So there's superposition error.
yeah, so for that remember for the V-shaped block is the data locator data is the center because it's not straight it's a ray is a
Tangent.
no tangent.
Tangent to the circle.
It's tangent to the circle to the center to the circle. So the locator area is here. The V-shaped locator is the center of this one. Is the center, okay?
Yeah.
But his operator data is here, right?
Yeah.
Its operation data is here. So there have some there is superposing error, right?
Yeah.
So what is the superposing error?
Delta Y.
Delta B.
Okay.
Delta B. Delta B is the back to go over our class, okay? Delta B is the data non-superposing error, right? So how to calculate the delta B? Huh? How to calculate the delta B is how to calculate the non-opposition error.
Delta. What's that symbol?
Huh?
That symbol. Alpha D. Is it delta or?
Torus. This one.
Oh, yeah.
The torus. So the delta B means that this different data. Torus. The tolerance between different data. So like this one is the center to here.
Yeah.
So this means the circle to here is tolerance. tolerance is from here, right? It's from here.
Yeah. So
It's a circle, it's a big circle, it's a half the this one.
0.1.
0.1, right?
Yeah. Okay.
It's 0.1. Is this is a distance? It's distance from here to here. Right? The bigger one, the big circle. The big circle, the total tolerance is 0.2, right? The half of the tolerance is 0.1, right? And the superposition data and another data is this is the superposition data, superposition data. And another error is location error. Is the V-shaped location error. How to calculate that one? Data one, right? So how to calculate the data one? Back to here, it just we have calculated the three situations, right? First one, second one, third one. The first one to make sure this distance, right? The slot, mini slot here, right? To make sure this distance, the dimension, right? The second one to make sure the dimension here. So operation data is here. The third one is the same with this one.
Yeah. So it's gonna be.
So gonna be the B is here. The data y is here, right?
This alpha E divided by 2 minus tolerance D over 2.
So this answer is this one.
Yes.
Okay, just to make sure this distance.
Yeah.
Make sure this dimension this distance. So the answer is this one.
Actually, what is the rho D is 0.1, right?
Delta D.
Yeah, 0.1.
Delta D. Let me see. Delta D. The delta D, yes. Delta D is 0.2. Is the tolerance here? Here. Delta D.
They can know that the way is that one, right?
What?
Yeah.
That's the one that they want.
Yeah.
But it's not the same information.
So this one is delta D plus 2 then
But it's something
F divided 3, okay?
Yeah.
So delta dw3 W is delta Y
Plus
plus delta B. That but this is minus delta B. So this is the you said that is plus, okay? This one. So equals delta D plus delta B 0.1. And then she calculated the answers, okay? Understand?
90.
90,
Alpha is 90.
and
Right, Kaushik? Alpha is 90 degrees, right?
Huh?
The alpha.
Alpha is 90, yes?
90. What divided by 2? Yeah. That's what's alpha.
Okay.
Okay. Last, do we have to send it in or it's okay?
Huh?
We in school, do we have to send your email
My email,
or it's okay?
you can send to my email. Okay. You must send to my email the result of the final result.
I saw it now, I showed you. If I finish now, I show you. So,
Yeah, finish that and send to me and send to my email.
okay.
Finished this one.
We didn't send you last time.
But last year, they sent to my grandma.
Huh?
Very good.
They sent my grandma.
You don't want to send my email?
No. She said she doesn't understand something.
You
We send
understand?
your email, no problem.
I'm not there.
Go where? Go back.
The home now. Yes. Here there is.
You have the PPT. I sent you to group.
I want to know why in this homework we this formula with our and then the first one is down.
Which first one?
The last in the last one use the our X Y.
Because that one has no angles.
You mean this one? Why this one is X as maximum or it is the tolerance plus the minimal, right? Because this is the part, this locator device is pin. This is V-shaped block. This device is V-shaped block. We need to calculate when we use this method, this locating method, and to calculate the error, the location error. But this situation, we just use the pin. Understand? Understand? It means when you use the pin to calculate, to suppose this workpiece, and to calculate the location error. This one is like this one with the pin. This is the pin. Example A, example 1. This is example B. This is example B. You got to understand here. This is the support is the pin or the manger, or pin or the manger. This is V-shaped block. This is locator device. Continue. Okay, continue our class. So another is determination of the active position of clamping force, because we analyze the first point, the from what direction to add the force and to divide and to reduce the workpiece deformation, right? And then this class we want to talk about how to calculate the force. So how to calculate the force, the clamping force. The active point of clamping force should be near to the surface to be machined as far as possible. Yeah, this is what we talk about. We already talked about that, right? The force should be near to the surface to be machined as far as possible. Auxiliary support is added to the part with poor rigidity, replace it. So like this is the workpiece, okay? The dot, this is the workpiece.
Yeah.
This is the workpiece, okay? This is the workpiece. So this is something to be machined. This is something to be machined. So when you to machine this surface, mainly the surface, okay? Mainly the surface, and you use this clampy to clampy. You use this. This is the fixture to clampy and clampy. This fixture to locate and clampy this workpiece. Okay. You analyze the locate device. What is the locate device?
It's a pin.
It's a pin here, right?
Yes.
And it's surface. Surface is the locate area, locate device, and the pin is locate device. And this is the clamping first, right?
Yeah.
Because you need to manipulate this surface, and you need to design this auxiliary support, because you need to design this first. If you don't to add this one, design this device. So when you build it, because when you build the surface, you produce the first, right? You need to let this focus down, and the focus to deform. So you need to add this auxiliary support. Okay. This auxiliary support is like this one. And the proper contact for and the proper contact form of clampy point can reduce the clampy deformation of the workpiece, improve the contact reliability, avoid clampy element damage the location and the surface of the workpiece. So like this one, this is what?
That's
Clampy device. So like this is the clampy device, right? And this is the point. This point is contact this surface because this is it's one point. If there's a force, the one point can produce a big pressure. The pressure can be damage the surface. So that's not good, right? If this surface have a very high pressure, so this is not good. Not reasonable, right? So we change to this one. So this one, this is clamp here, and this is a large plate. It can contract this surface. But not very small, it's a large. So the pressure is not very big, right?
Yeah.
So we can use this one. And so this one, the B, the figure B, we just if we just two or one can check to here, it can to make this one is the information. But use 3 or 4 it
Balance.
is balance this one, and also the it can to make it deformation, just the workpiece deformation. Okay. So this one is means how to calculate the clamping force. We can use a device to magnitude the clamping force. If like the screw, we just use a very small force, and the screw will produce a very large force to clamp the workpiece. To determine the magnitude of the clamping force. So the magnitude of the clamping force depends on that the cut force that establish and solve the static equilibrium equation, including cut force, gravity, and workpiece. So when you calculate the force, you need to balance all of the force worked on this workpiece. It means that you need to establish and solve the static equilibrium equation. So how to calculate how to establish the equilibrium equation? That's very hard, right?
That's really.
Huh?
That's very high.
Not very hard. Okay, let's give you an example. Okay. And every initial force and centrifugal force. So the theoretical clamping force FR, this is theoretical clamping force FR can be formed. Practical clamping force. So the FR and this is the practical clamping force is to multiply K. Okay, usually K equals 1.5 to 3 or 2.5 to 3 for rough machining, and K equals 1.5 to 2 for the finish machining. So it means that you use the theoretical FR and the practical is magnitude is 1.5 and 2. In practice, the experiment analog method is often used to estimate clamping force. But the important feature which is used in the critical operation, clamping force is usually determined by experiment. So the clamping force we can get from the experiment.
One second.
Huh?
1 second.
Give you one thing, okay? It's just how to calculate the clamping force. The practical clamping force. Let's give you an example, okay? So like this one. The operational principle of clamping device with wedge. So this is a wedge. So this is what?
And that's the workpiece.
Yeah, this is the workpiece. This is the pin, is the locator. And this is the width, this one, and to support the weight, support the workpiece, right?
So last we try the wedge.
This is the weight.
Why?
And this is the first here. This is the weight, okay? And the first is here. Put the first here and to support this support and tie this workpiece, right? Okay, and the application illustrates weight clamping. It's a weight clamping mechanism here. And this is the weight is the same. When this is the screw, right? Screw here. This is the weight, right? The weight is transferred first here. First here, and this is the device. This is first is down, and this is here. It's to fix and clamp this workpiece very tight. Got it? Okay, how to calculate that? So here to analyze the weight, the workpiece, the first acting, the weight in the clamping schedule are illustrated here. According to the principle of static equilibrium, there is so. Can you to calculate the or can you to analyze the first on the weight and to establish the equivalent meridian equation and to calculate this the first. So unlike that, you think it's not very hard.
So what's that look? Try.
So try to analyze this one. This one is from this one. From this one. So this is weight first. Because the weight is have a first from this workpiece, right?
Yeah.
And the weight have a first from this workpiece, this one, right? So this one give a first to the weight, and the workpiece give a first to the weight, right?
Let's
Think about that. Okay, to give the equilibrium equation to the weight. This means give a hint. The hint is that this is the first from this clamp first here.
Yeah.
Clamp first here. The clamp first here is from here. It needed to balance this one and this one. Got? So the weight is you can get have a first from direction from the perpendicular or from this one and perpendicular first from FW. We need to calculate this direction. The horizontal direction first and establish the equilibrium equation. Balance from the horizontal. So it means that the F1 plus FRX equals FQ. It means that FW and plus F1. This is F1 and F1 is F1. F1 is F1. F1 plus FRX equals FQ.
Yes.
So this direction is balanced.
Then last FW.
You got FW.
Yeah.
FW is known.
Finish. No. I mean yes, last FW and alpha equals F1. So cut off.
This one?
No.
Go down.
Last no, go
Go back.
No. Next.
Legs still slide.
Yes. So the F1. The F1
Equals
equals the FW and
F1
the angle
angle phi1.
phi 1.
Yes.
And then the lower side we have the whole angle down there is alpha. This
From
angle
alpha here
from there to there is alpha, right?
Yes.
Yeah, so
So the alpha x equals
yeah, because FRY
yes
tan
this angle
5 2 plus.
2 alpha 2 okay.
Yes, that's most definitely.
So this is F1 and FRX, right?
Yes.
And then Clampy first FW generated by the wedge, right? By the wedge, it means that this is the first push this wedge, and the wedge is support this workpiece. So the FW equals this one plus, right? And equals FQ and divide 10 by 1 plus 10 alpha plus by 2, okay? And where the FQ is original driving first, is from here, it's driving first. FW conquer first of the clamping first produced by the wedge, okay? Phi 1, phi 2, frictional angle included between the wedge and the workpiece. So alpha is the ascending angle of the wedge. This is the ascending angle of the wedge. So alpha 1 and alpha 2 are very small. Got if the
very complex.
it's phi 1 and phi 2 are very small, it means theta 1 equals to 2 equals alpha. So this one, this one change to this one.
Yeah.
Alpha plus 2 phi, because he said that phi 1, phi 2 are very small. And to simplify the equation, okay? Just to understand all it's okay. And the alpha clock condition for wedge clamping mechanism. It means this is a push force here, right? When you remove the force, there's no force here. So the wedge is still in here. It can't to, if there's no force, the wedge cannot to remove, right?
Yes.
So it's called self-lock.
It locks by itself.
Yeah, it locked by himself. Self-lock, because it's a wedge, right? You give the wedge first to support the workpiece. Like this one. You give a force to support this workpiece, right? The target workpiece. When this force is removed, so the wedge cannot go back by himself, and the wedge just steer in there. So it's called self-lock. So self-lock means that after the workpiece is clamped, even though the original driving force is removed, the clamping mechanism can still keep the workpiece in clamping stature. That means a static friction force. Friction force is means here, so there's no FQ. That's a friction force. The friction force, because the wedge just to slide down, so the friction is here from this direction. Got? It can be seen from here. The direction of the frictional force F1 is contrary to the disengaged tendency of the wedge. In order to ensure the wedge in self-lock status, the following conditions should be met. It means that the FR1, if the FR1 is larger than the FRX, right? And the wedge can keep steer on the stature. So you can analyze the force balance, and the FW phi 1 larger than FW 10 alpha equal balance phi 2. And also they are very small, so we can get this wedge, this angle must equal phi1 plus phi2. It means when the angle smaller phi1 and phi2, then the wedge have a self-locking property, self-locking properties, self-locking mechanism.
Yes.
If the alpha larger than phi1 and phi2, it can't have that property.
Oh,
Got it?
yeah.
Okay. If the alpha smaller than the phi1 and phi2, it can get these properties or the principles of properties. And this is the clamping device with which is IF. IF is the ratio of the clamping force to the original driving force. It means when the FQ is small, the FW is large. So if can to magnitude the clamping force. So equals 1 divided 10 phi1 plus 10 alpha plus phi2. So clearly the smaller the wedge angle alpha, the larger force transmission coefficient IF. So when the driving force is deflate, the smaller alpha, the larger the clamping force FW. Set alpha 1 equals alpha 2 equals alpha equals 6 degree. So if the smaller, the angle is very smaller, it's just 6 degree. And the IF equals 3. It means when your driving force is 1 new, and the clamping force is 3 new. So it's to magnitude 3 times, right?
Yes.
So it can to magnitude the driving force with this clamp the wedge.
That's very complex.
Yeah. So the clamp is the first, is the magnitude of the force, the driving force, the clamping force.
Oh, yeah.
The height S is called the clamping jolly of the wedge. Is here S is the clamping jolly. S, this one. This one is the clamping jolly. It's called the clamping jolly of the wedge. So S equals L tan angle. So you can just see S equals L tangent angle here. You can analyze that.
This clamping journey means it can move.
Yeah, it's jolly. It means that this wedge can move this wedge can this direction move distance.
It can move this way.
This way.
That way. Or
This way, move this way distance. If it means if from here in front, this is the wedge, right? If this wedge move from this way, and this workpiece is to light from this way. Not from this way. If the weight is here and the workpiece is here, right? If the weight is go forward this way and the workpiece is go up, right? It go up. So S is the jolly distance. Distance jolly. It can to calculate. Where? So you can to calculate that. This is if you can to analyze that. You can get these answers. Get these equations. S equals L tangent alpha. So the clamping device with which the characteristics of the clamping device. The simple structure, right? It's very simple. Just is a wedge. And a good self-locking function, right?
Yeah.
When the drive force is removed, the wedge keeps status. Keep the same status, right? It's the first magnifying device because if the angle is 6 degrees, so the magnify force is 3 times a small clamping force. There 1, 2, 3, 4. The first character characteristics is the wedge. So when the wedge clamping mechanism with both self-locking function and larger clamping jelly is required, the wedge with two ascending angle can be used. In practice, the wedge clamping mechanism is rarely used separately and often used together power clamping device for clamping the surface with good quality. It means that the first with a power device, like use the manually or the automatically is used pneumatic first or the electronic first, like this one, the first one, like this one. This is the wedge, right? The wedge, and use pneumatic first, like this one. So this wedge cannot to use by himself. He used by give a power source device together to clamp the workpiece. So several common used clamping mechanism. The clamping device with screw mechanism. This is screw. This is screw. Is screw the workpiece. That's the screw that, and it can to tighten the wheel. And this is the calculation the clamping first for the single screw clamping device. You can just think about that to analyze his force and get the static equilibrium equation, like this one. This is the screw. This is the screw shape. This is the screw radius. Yeah, because the screw is the screw, the circular, and is a smaller diameter, the bigger diameter, and also is a middle diameter.
Different sizes.
Got that? Screw. Have you known that the course is called mechanical design? Not this course. Mechanical design, fundamental mechanical design. The screw is a very classical part. You did it.
We did.
You did.
It's true. But actually, it was just drawing. We didn't really do much like screw, bolt.
Yeah, screw and bearing
Yeah.
and some. No, you have not learned that course.
Did drawing. Okay.
Drawing.
Right.
The design of the one.
Machine design.
Machine design. Mechanical design,
Design,
machine
screw,
design, the
design.
screw, and the bearing. You just think about this. Just know the shape and his characteristics of the part. Very classical part. And another one is the clamping device with eccentric mechanism. Eccentric is the same because when you hold this one go forward, and because this is a eccentric distance, right?
Yes.
It can to tight this clamp the press plate down and to clamp this workpiece well. This is how to calculate his force. Okay, this is I think it's it's very hard to understand. Very hard. You just to, if you have interest, you just to analyze that. Okay, if you're interested, you analyze that. Okay, so next we just to talk about the indexing device. So what is the indexing device?
Machine. This is what this is surfaces. All slots of television, which are required to machine
The concept of the index device. So emotionally, we often see some workpiece with a group of surface, whole slot or polyhedral, which are required to machine the one-step installation on fixture. The group of surface is distribution in the certain angle or distance. It means that if this one, so you need to drill three first, right? Three holes. You drill the three holes, and you put a workpiece here, and you because these three holes is distributed or 120 angles, right? Because the circle is 360 and the one circle is 120 angles, right? So it's required the feature should have the index function. It means that when you drill a hole and you just to rotation the workpiece 120 angles. So how do you calculate this workpiece rotator? That is called the index device. Okay. And after the surface is machined, some part of fixture together with the workpiece on it turns a certain angle or to move a certain distance, and to machine another one. The device which can change the machining position of the workpiece in one installation by turning a certain angle or moving a certain distance is called the index device. Index device. Element of the index device, so-called index device, is widely used in practice. So like this one, you can drill the hole and drill this hole, drill this hole, drill this hole, drill this hole. And when you drill this hole and you use this one, the index device to rotate 90 degrees to drill this one, and then rotate 90 degrees to drill this one, and then rotate 90 degrees to drill this one. Okay. So this one is rotary jig used for drilling three radial holes uniformly distribution on a sector workpiece. Okay. And the two guiding element, the drilling bush. A drilling bush is a special element of the drilling jig. It functions in its guide the drill, core drill, or rumor to prevent them deflecting in the machining process. There are 4 types of the drilling bushes. So this is the drilling bushes because when you're drilling, it's to deflection, right? Deflecting. So you use the drilling bush to guide the drill to get the right direction. So a stationary drilling bush directly passes into the hole on the drilling jig. It means that this is the drilling bush, and the drill will go through this hole, this hole, and to drill the workpiece. This is to guide the drill, and to add to prevent the drill deflecting. So with the 50H7, this is N6. Do you know this? What's the meaning of this one?
Yes. The hole is H7. Around the hole.
So this is this is the match here. This is the shaft. So this is the hole. Got that? This is the hole. This is the shaft. So this hole is 7. So this is the shaft is 6. So the drilling bush has high position accuracy, but not easier to replace it. This is the interface match. The clearance fit and transition fit and interface fit. So this is the interface fit. It means that this is the hole. It's big. It's smaller than the shaft. So it's the interface match. So has a higher position accuracy, but not easier to replace it. You cannot remove it.
Yes.
When we get a break, when will we get a break?
No.
Now.
And actually, no break, we close early.
The break.
Yeah, we close early.
Close earlier. Okay,
Actually,
get
break is okay.
get break time. Just a 20 minutes break. Okay.
Break, no.
Back to our class.
Yes, class.
Continue our
Continue, class, guys. Class. Yes, class.
continue to our class, okay?
Yes, class.
So we talk about the guide, the tour guide, okay, is commonly for the drill bush. The height edge of the drilling bush is the length of the guide hole. It means that this edge is the head, is a drilling bush. So it's a guide hole. So it's a guide hole is here, is edge. So how to determine how to design the edge? The edge is basically equal 1, 2, 3 times of D. D is the diameter of the bush. Okay. So this is the generally the edge is depth, the length of the height of the edge. The diameter, depth, position, accuracy of the hole to be drilled, the workpiece material and its surface, function, stiffness of the curvature, and so on. So it means that the edge determined by the height, the drilling bush, the factors. Okay. So the edge is usually equals 1, 2, 3 times of the diameter of the hole. So if the hole is located on the slope or the curved surface, or has a higher position accuracy, then H equals 4 to 6 diameter. Like this one, this is and later we will to talk about the hole located on the slope or the curved surface. Okay, and the drilling bush, another one is the renewable drilling bush. The renewable drilling bush is suitable for drilling hole in large volume production. It means the drilling bush can be reused, and there is a lining bush between the drilling bush and the jig plate to protect the jig plate from wear. The fit in between the drilling bush and the lining bush is F7, K6. So this is clearance fit. Clearance fit because you need to put the bush out, remove it, and to remove it. And to renewable the drilling bush, it means when you screw it well, and when you remove it and to lose the screw, and then to open the bush. And the rapid replacing drilling bush, the kind of the drilling bush is suitable for the drilling, hole drilling, and reaming the one operation. So this is another one, another bush, because the diameter of the cartridges used in drilling, hole drilling, and reaming is different. The drilling bush is with different inner diameter and leaded to guide the different characters. The use of the rapid replacing drill bush can reduce the bush replacing time.
I need to ask you for a favor.
Fever, you?
Yeah.
You fever?
I need to ask you for a favor, Lash. You ask us to bring our forms and we didn't go because we had so many classes and the teacher said we'll go at 5. So I need to go take a dormitory and leave it, so I'll come back right now.
You are new, right?
Yeah, but I'll come back right now. I'm going
Okay.
to just send it to the office and come right now.
20 minutes. You'll come back.
Okay.
Cheers, Lash.
Okay. Last.
Continue our class. So this is the spatial drilling bush. It means that to drill a slope hole, they drill a hole on the slope. So the bush is like this one is a slope, like this one is true because we need to drill a hole in the slope and use this bush, and drill a hole in concave pit. Use this bush to adjust the shape to adjust the shape to have the same shape with this workpiece. And this one, yeah, bush the hole. The drill 2 holes with very small central distance. This central distance and use this like this one. This is the bush. Just design the bush. So when the standard drilling bushes cannot be used because of the limitation in the workpiece shape or the milling or the machining condition, so it's necessary to design the spatial pulse drilling bush by oneself. So this is spatial, but this one is a very common bush. So this spatial bush just to adjust the one slope, the one spatial conditions, drilling conditions.
You show us like push to the video from the lights, from the video,
You reduce.
Yeah.
This is the bush. Okay, we have the same. This is the bush.
So it's the same like oh.
Yeah, this is the bush. Here, this is the bush. Because we need to drill the hole, and because the drill is very long, right? The drill is long, so when you drill the hole, the drill will deflect. Yeah, so we need to push here and to guide the hole, guide the drill to drill this hole. So commonly, when we drill the hole, we need a bush.
So how do you differentiate the push from the hole?
Huh?
How do you differentiate the push?
How do you deflect the shape?
Differentiate. What's the difference
What's the difference? What?
between push and the hole?
A bush between bush and hole. This is a bush.
Yeah.
This is the shape is different, like a sleeve.
Yeah.
Like a sleeve is here. This is the bush. Hole is here. The workpiece to dig the hole to drill the hole. This is the shape is different. And this is the bush. This is a rapid. This is like this one. Is a rapid replace the drilling bush. This one is rapid replace the drilling bush. This is a screw. When you tighten the screw, and the bush is tight. When to lose the screw, and you can change the bush. And this is the tool aligning device. The tool aligning block is used to decide the position of the cutting tool relative to the locator on the fixture. It means you put the fixture here, right? You need to drill the hole. and the driller, you get a right position to the workpiece, and then you go down. If like a 5 millimeter, it's a drill the hole. You need to drill the hole. The hole's depth is 5 millimeter. So the first thing you need to get the cut the drill, the tip into the workpiece in the surface in the workpiece, get the right position, and you control the machine tool to give his code like the 5 depths of the drilling. So we use the tool align block to get the right position. So the mutual position is turned up by means of filler gauge to avoid damage cut edge of the promoter wheel of the tool align block, like this one. Well, they have a radio. A radio is the tool aligning device. This one. So the driller touch the surface and the light is on, right? This is the drill block, is the align block. So this is the right position, and you put it. This aligning device. Okay, this is a drill. When the drill touch this one, and the light is on, that is the right position. And if the drilling depth is 5 millimeter, if the drilling depth is 5 millimeter, then you can give this machine tool like a program, a G program, so that it's down 5 millimeter, and you can get the right position, right?
Can you show us there the filler gauge? Filler gauge.
The filler gauge is this one? The filler.
Yeah.
Another one is like this is this one. The touch, this is like gravity. This is the same. If just to touch it, and this is get the light is on, and to remember the right position. And another one, let me see, is this one.
第一步，使用主轴单面将对到以压制零位，并将相对坐标清零。第二步，通过刀尖将对到以压制零位，并将刀具长度输入至对应刀口当中。第三步，使用刀尖触碰空间底面，将当前位置设置为94，最多0点，并减去一个刀具长度。最后通过程序验证。
This is means that this is a gauge, and the drill to touch this one and to remember the position here, and another surface touch another surface to here to touch this one and to remember this position. And this is the workpiece. So you can to remember this surface, the top surface of the workpiece, and to adjust the program, the G program, and to get a right position, the right drill depth, or this way, or this the depth is here. Is if the 5 depth, the 5 millimeter, and you go this way. You go this way is 3 millimeter. You can get the right position, the right dimension or right position. this is the filler gauge. Filler gauge is to touch it and to feel this is like on. So this is the true aligning block. This one is true aligning block, and this is the filler gauge. This one is the filler gauge. Another device is the collecting element. So what is the collecting element? Because the fixture needed to collect on the machine tools, right? So usually we use the T slot like this one. So this is the fixture, right? The fixture needed to fix on the workpiece or on the machine tool, right? This is the machine tools. Machine tools needed to drill the hole. So this picture needed to fix on the fix on the machine tools. So you need a T block to fix it, and this feature can to steer on the machine tools. So the elements used to locate and clamp the feature on the machine tool are named as the collecting element. Usually use the T slot. The feature is the milling machine, shaper, and player, and the boring machine are located by location keys, which are fitted with the T slot on the workpiece. So this is the machine tool. The machine tool. This is the workspace. The workspace, and this is some. Let me see the machine tools and then the video. No, the video not. Let's see. So the machine tools like some slide like give your examples like to search machine tools. Here. So like this one, the picture. Can you see this picture? So this one, this is a slot here, right? The slot here. So this one put in the slot, put in here, the workspace, put here, right? So the fixture put here, and then use a T block to collect it. Got the T plate like this, like this one. This is the screw, the T slot, the T slot, and use this screw to collect the fixture to the machine tools. Got? Okay. And another collecting element, the fixture used on both the laser and the insular or external grinding machine and generally is stored on the spindle of the machine tools. It means that this is a spindle. This because when you so this one, this picture, this is a drilling machine. This is a drilling machine. So this is a spindle. Okay, this spindle can rotate very quickly, right? The spindle is to collect a drill, right? So how to collect a drill? So there is a fixture to collect the spindle and collect the drill, right? So this is the spindle. Spindle with the spindle is hollowed. It's hollowed, and this is hollowed, and this one is to collect the drill, and this here can collect the spindle. So feature this is called feature with a more taper shank. high location accuracy, but low stiffness, because this is very non. Its non has a low stiffness, but it's a tape. It's a taper. So taper it means it has a higher location accuracy. And the second one is the Fixture is located on the spindle with the end surface A and the hole D. So this is a Fixture. This Fixture can collect A and D. So the C is the Fixture is located on spindle with the end surface T. This is T. It's T and a short taper surface. So this is a short tape surface, high location accuracy and high stiffness, because this is not very longer, so it's high stiffness. And the location is a higher location accuracy because this is a taped. So taped has a high location accuracy. So the basic requirement for the design of the special purpose fixture to ensure reliably the machining accuracy of the workpiece. You need to ensure the accuracy of the workpiece to determine the correct the location and the clamping planes. So the very important device is the locator device and the clampy device, because you need to fix the workpiece here and the clamp it tight, and then you can drilling or machining, you can get a very higher accuracy. To select or design the locators, clampy devices, and the true aligning element. The true aligning element, maybe you can choose it to improve the productivity and reduce the product cost. Yeah, because why do you design a fixture? Why did you design a fixture? Because you need to machine a batch of the workpiece. When you machine a one workpiece, you don't need to. If you just to machine a one workpiece and you design a fixture, so you can cost very cost. You cost a lot, right? So when you design a fixture, you need to machine a batch of the workpiece, so you can reduce the cost. The convenient for use, a good manufacturing, good manufacturability. So I mean that the fixture is easier to machine. Approacher and producer for the design of the spatial post fixture. So to be clear about the design task and collect design information, to draw up the structure schedule and draft the schedule of the fixture. So how to do design a fixture? The first thing you need to clear about the task and collect the design information. So for example, you need to design this one, this fixture. So you give you a workpiece. So this is your workpiece. You need to design a fixture to machining 1,000 or 1,000 or 10,000 workpiece like this one. How to design the fixture? First thing, you need to analyze the characteristics of this workpiece. This is a circle, and then you need to draw the hole, right? So how to draw the hole? The first thing you need to think about how to put the machine, how to put the workpiece have a right position. How to locate the workpiece. How to locate the workpiece. Huh? How to locate the workpiece? You can think about his characteristics. So this is the hole. So the hole, maybe you go over what we learned. What is the locator to what kind of the locator can to locate the hole? Like a pin and a manger or the V-shaped block, right? V-shaped block you can to locate the hole, right? Locate the shaft or locate the hole. and also the manual can like a pin to locate the hole, right? So like this one, like this situation, they can it use this long pin and very short plate to locate the hole, like this one. To locate it is here. So when we use these locators to put it here, so this workpiece just drill or just rotate. The workpiece cannot move from this way, cannot move from this way, right? Cannot move from this way, right? So it's located, and the rotation around X, rotation around Y is also restricted. Just use this locator, right? It's a long pin and a short soldier or solid plate, solid plate. Okay, and then and we use this one to locate the degrees of the fringe and how to clamp it. So like this situation, you put it here, you put the features here. This is the plate and a pin, a two pin to locate it here. It's very well. And how to clamp it, and then you can think how to clamp it. How to clamp it? Like this situation, we use a screw, like this one. This is screw to clamp it. Like this one, this is screw to clamp it well, right? And this is a bush, right? This is a bush because they drill the hole. So you can use a bush to drill the hole. So the fixture is done. So give you an example. So give you questions that like this one. See this one. This is a workpiece. So illustrated a hole making. So a case of special purpose of feature design is illustrated a hole making operation drawing a rocker arm. Give that the rocker arm is made in batch of production because it is to make machine a lot of the workpiece, right? Its blank made of 45 steel is manufactured by die forging. An upright drilling machine with model Z525 is selected. This is a machine tool. It is required to design a drilling jig to realize the machining of the hole 580H7. You need to drill this hole, right? To drill this hole, how to calculate, how to design a fixture. The first thing you need to think about how to locate it, and then how to fix it, and then because it's a drilling, you need a bushing. It's a drill bush, right? To drill the hole. And think about that. How to locate it. Drill this hole. This one, yes, because you're drilling a hole of 518H7. Drill this hole. Think about that. The locator device. This is simple. It means data. Locator data. This one, locator data. This one, locator data. This is simple. So for your program, for your graduation program project, for the graduation project, maybe let you to give you your question, just let you to design a fixture. So give you a workpiece like this one, the workpiece like this one, or like a little complex workpiece. And you need to design a fixture, how to design a fixture, and to calculate his locator error, and to calculate the clamping force, and then to design a fixture. So like give you this workpiece, how do you to design a workpiece, to design a fixture? Huh? So it depends on you, the style or unstyle, just to put, just to fix the workpiece the way and put on the drill machine and the drill report. This is the workpiece. This is the workpiece. It's a tricky workpiece. You mean what? Fixture on outside. It's here. So this means that this workpiece is. You mean that let me see. You mean that you put the fixture like this one, or like this one, like this one, like this one?
No, it's also.
Huh? Use what? Use what to fix it or to locate it?
So, structural.
What do you mean?
The scheme of the feature.
Hmm?
The scheme of the feature.
The theme of the fixture.
Yeah. Scheme of the feature. Very first.
The theme of the fixture. Okay. Have some ideas?
Yeah.
Okay. You want to draw? You how to fix there? No, you mean that you need to calculate it. No, this question that you need to design a fixture, not to calculate his location area. Okay? So to fix that design the fixture. So how to design? This is very complex question. Complex question. I mean, just need to design the locator device and design the clampy device and design the bush, the jiggy bush, right? And to design a fixture. Design a fixture to clamp, design a fixture to fix this workpiece. And then put it here, put the fixture with the workpiece into the machine to drill the hole. Like this one. Okay? Either to drill, either to design this one. Like this one. Similar to this one. And this one is also the same. Because you need to drill this hole, right? So he drill a workpiece like this, like here, like this. This is the locator pin to locate this surface. And this is the clampy. This workpiece here, and then drill the hole. This is the clampy device. This is locator device. Here is the locator device, and also this is the locator device. Just use the screw to clamp it. Design the fixture. Okay. Any questions? Do you have any ideas? So let me think about, to drill the hole, maybe you can to use this is a so-called cylindrical. So what kind of the locator can to locate? What kind of the locator device can locate or restrict the degrees of the freedom for the cylindrical? Huh? We shape the block, yes. And so this is a hollow. I mean that when you drill this hole is already drilled because we use this one to make a data, add the data, right? So this is already drilled. So this is a hollow. This is a hollow. So we can use what to locate that? Main drill or pin, right? We can use a main drill or a pin to locate that, right? So like this one, this is the V-shaped block to locate this surface, right? Cylindrical, and the pin and the shape, the plate to locate this hole. So how many degree of freedom is determined, is restricted. So like this one is x, y, z, x, y, x, y, x, y.
It's not fixed.
Yeah, I mean this one is x and y, right? This z position, this z direction is not fixed. But we have another one. This one, the pin is fixed the z, right? Huh? The round x around the y is also fixed, but around the z not. No, z is also fixed because this is collected, is one part, right? It cannot rotate around the z. Well, there are two locator device. So x, y, z and around x, y, z is also fixed. So this is how to calculate the locator error. Okay, the locator error. This is very easy to calculate the locator error. And this is the bush, the tour guide device. Okay, the tour guide device, and design the clamping device. So how to design the clamping device? So ready to locate that. This is the bush. Okay, and how to clamp that. How to clamp that? Think about that. How to clamp that? So we use what to clamp something. Sometimes is a screw and a wedge. And what learned to clamp some clampy workpiece? Just the screw and the wedge, right? So like this one, we can use a screw to clamp it because this is a circle, it's a cylindrical. So the cylindrical we can to length, we can to extend this one, and to put a screw here and clamp it, right? Just to clamp the workpiece well, right? Like this one with clamp it, right? Clamp it well, right? And arrange auxiliary support. What is the auxiliary support? And another one, this is screwed here, but this way, we use let me think. This is a V-shaped block, right? So this is a V-shaped block, right? So we use this screw to screw it where? Got that? This screw to push the workpiece. To put the workpiece contact the V-shaped very well, right? So we use this screw to push it well. So like this situation, we just use this way, this one to push the V-shaped screw it very well. Got? And this is put it very well. So this is support it in the base. So this one is the base. So you can see, you can design a base like this one. This is the bush, right? The drill bush. So this is the base because the drill bush is to collect the base. This is the base. So you need to design a base to collect to the machine tool. Use the T-bolt. And until now, the fixture is finished. And then you should draw the general assembly drawing of the fixture to mark the dimensions, tolerance, and the technical requirements. To parallelize this between the central lines of drill bush and the location pin is 0.02. The symmetry of the symmetric plane of the movable V block relative to the central line of the drill bush is 0.05. It means that you need to add or mark the dimensions, tolerance, and technical requirement. Like the tolerance, because this is the match, like the 528 F7 M6. It means that this one to match this one, and this one to match this one. You match is the interference or the clearance fit, or the interference fit, clearance fit, or transition fit. Okay. So that is all the design. Is it hard?
Yeah.
Huh? So for you, like for the if give you a program is a graduation project, just to give you a very simple like this workpiece, and you need to design a fixture. So the first thing you need to know how to use the software to draw it.
SolidWorks.
Yeah, SolidWorks or the Career or the UG or your software you need to use. Very skilled at it. Skilled at this SolidWorks and to design it. And then you need to know the course of this one, the fundamental. Yeah, you need to calculate the locator. Because you need to design the locator devices and clampy devices, and also calculate the locator errors and calculate the clampy forces, right?
First of all, you need locator device, clamping device, and the third one.
And so the one you can calculate the locator, the base,
Yeah.
the base and the bush or something. These are the collected devices. Okay, and then you need to calculate the locator error and calculate the clamping force. Yeah, and then you finish that and you need to mark the dimensions. The mark the dimensions you learned first year, right? Enjoy and tolerances. Tolerances you learned last semester. The tolerances and the technical requirement, like this is roughness is what, and the parallel to here or something like this one. is the tolerance is and take liquor requirement. So that's done. And the last thing you need to give somebody is a CAD drawing.
CAD drawing.
Is drawing.
Yeah.
So because you design the fixture, right? And you need later the machine engineering to make it. So how does he make it? He can get a drawing. So you can to have some drawings, right? Have some drawings for the assembly, for the workpiece, for the locators or something, all of that, and to give them to the machine engineering and to make it. So that now.
The material size.
Yeah, size. Yeah, so that now. So you just to make to design a fixture.
Do you think if you select that subject or you to design out, I think it can be all for graduation? For graduation.
Yeah.
If you design only that.
Yeah. Yeah. If you can design it, you can get a graduation. This is for this course. Yeah.
For a graduation, we gotta choose a course.
Yeah. You can choose it's a question, you choose a title. So there are several teachers give you several questions. And the title is different. The title is different. You can choose one. So some titles is about how to design a fixture. And some courses, some titles is some questions is about controlling something or something, I don't know. Yeah, so you can choose that. So for this one, the project for this one, how to design a fixture, just to design the fixture and drawing the features and get the assembly picture and then it's done. And also to write a design instruction or design instruction for about 10,000 words, maybe 10,000 words, 10,000, yeah, 10,000 words, yes. Yeah, and it's done. You can get a graduation degree.
But no 3D printing.
Printing?
No printing.
Printing. Yeah, you need to print. Here on campus, you need to print the words, print the drawing.
No, I mean the drawing, 3D printing.
3D printing? Yes.
We go to the.
You need to print the word. You need to print the drawing for on campus students. But in the online students, maybe they will to give the PDF. PDF. What? That's done. Okay, so the course is done. Where? Where? Class is done. Okay, please. Email. Who sent my email? I don't know.